write the domain notation x is greater than or equals to 5 using brackets. So this notation, the alligator bracket notation, the set notation, is equivalent to the interval notation x is greater than or equals to 5. So we start at 5 as the starting point all the way towards infinity. The starting point is a square bracket because we're going to include the number 5. We're including the endpoint. Now what about a number line? We could simply start at 5. It's our critical point here. And we can extend out towards the right. If you really want, you can even draw a solid dot here. This solid dot here represents including the endpoint 5. If this was a hollow circle, we'd be talking about a greater than 5. Let's write the range notation y is less than 3 using brackets and a number line. So the range y is less than 3 is equivalent to the expression from negative infinity all the way to 3. So we always go smaller to greater, and this bracket is rounded because we cannot actually equal the number in negative infinity. It's just an idea, it's not an actual number. And because we have a less than sign, we use rounded bracket here, not including the endpoint. If this was less than or equals to, this would be a square bracket. As for a number line, we simply draw a line from 3 all the way towards the left with an arrow, indicating that this number gets smaller and smaller towards negative infinity. And we have a hole here, signifying that there's no actual value, there's no solution at the exact value 3. So if this was y is less than or equals to 3, this hollow circle would be a solid circle. Let's write the domain notation for 2 is less than or equals to x is less than 4 using brackets. So here we have the set notation, and now we want to use interval notation. So we have 2 comma 4 rounded bracket, and the square bracket here represents we're including the endpoint. As for a number line, we simply do a solid 2 here and a hollow circle 4 here. And we shade in from here to here. So this here is a number line representation of the domain. Are the following graphs functions? For part A, we have a parabola. And what's happening here is we're passing the vertical line test. When you drop a vertical line, you can only hit at most once for this graph to be considered a function. So we can see that the vertical line hits only once here, one time. So therefore, yes is a function. For part B, when you drop a vertical line here, or even here, you're only hitting a maximum of one time. So we're going to say yes is a function. For part C, when you drop a vertical line, we're hitting twice. So this is not a function. No, it's not a function. We like the idea of a function because for any given x value, we only have one unique y value. If we say x is equals to 1 here, we can see that the y value is 1. Given a certain input, we get the output here. Unfortunately here, given a certain input value such as 4, we're not sure if the y value is going to be positive 2 or negative 2. So this is not a function. It's not fun at all. We call this kind of graph a relation. A relation includes graphs that fail the vertical line test. We have this nice rational function here. And as we drop vertical lines, you can see that we're only hitting once. Yes, it's true that this function is undefined at x equals 0, but overall, we're not hitting the graph twice or 3 times or more. So yes, this graph is a function. Now what about part E? We have a circle with radius 3. Is it a function? We drop a vertical line, we can see that we hit twice, so we're going to say no, not a function. Now what about F? You drop a vertical line here, yes, we only hit once. You drop a vertical line here, yes, only once. And when we drop a vertical line here, you can see that we're only hitting at this point here. This here is a hollow circle, so there's no collision. So we'll say yes is a function. And finally, for g, when you drop a vertical line here, it appears to be a function, same as here. But as you go down the middle, we hit once here, because that's a solid dot, and we hit again here. So there's two collisions. So we'll say no, it's not a function.